Prompt engineering is everywhere right now, but most of the time we pick prompts by intuition, not by measurement. In this video, I want to show you how to evaluate prompts properly. We will take a real world task, that is resume skill extraction, and I'll define some 3 prompts for the same input. Then using MLflow, we will systematically evaluate which prompt actually performs better using various metrics such as correctness, coverage, formatting rules, and even custom business level scorers. By the end of this video, you will have a clear framework to compare prompts for any LLM task, not by gut feeling but using reproducible evaluation. I hope you are excited. Let's get started. So before actually doing something and starting with anything, I would like to frame the problem and task clearly so that we both are on the same page. So first of all, the problem is that we have multiple prompts and we would like to choose one of them which is actually better for solving our specific task, right? Now LLM solves tasks via prompts. That is well known, right? So we have a task. It could be any task such as resume skill extraction or Q&A bot and things like that. We have an input and we have output A corresponding to prompt A, output B corresponding to prompt 2. Okay, so we have got multiple prompts and different outputs. So we would need a systematic way to choose the best one. That is why we need prompt evaluation. Now, what is the task that we are solving? The task that we are trying to solve is we have a resume, and in a real business setting, maybe you are associated with a HR firm that might be dealing with millions of resumes and that might want to extract skills from those resumes. So our task is to take the input as resume and convert that into a skills list. So essentially our input will be resume text and output would be clean list of skills. Okay, so we have a resume text as input. We will feed that text into LLM and prompts and we'll get clean list of skills, that is output. And here these two arrows represent two different sets of skill sets that we could receive via two different prompts. Okay, so essentially what we want to do is we want to compare multiple prompts. Okay, so we will have a resume text input and we will have a prompt A. So maybe prompt A would be maybe something like shorter version of prompt, and then prompt B might be instructed to extract in a very strict manner and also provide us the structured output. And all of these prompts will correspond to one output, not one output, because if you run the same prompt again and again, you might be you might likely to receive different outputs. But the idea is that the more detailed the prompt would be, the likelihood of the output would be same, would be very high. Okay, now the next thing that we need to think about is, let's say I have got 4 prompts and I would like to understand which prompt is better. Like, how do we mathematically and objectively define that a given prompt is better? Okay, so we have various metrics and we will be using MLflow inbuilt metrics and some of the also custom scorer based methods that are provided. So we have got things like correctness. Now what is coverage? Coverage is nothing but a guideline based metric that we will be defining. We could have custom business logic. So all of these things we would be defining in the code that we will be writing in a moment. Okay, so we can have LLM based scorers. Essentially LLM based scorers take your LLM output and the input, and it tries to, based on its capability of language and reasoning, it tries to understand the output generated by another LLM and give you a sense of semantic quality of how much the outputs are related to the input. Then we could have rule based scorer, in which we can take the output and we can apply some heuristic rules, such as maybe calculate the length of the output, or maybe split the text, split the output by comma and try to see how many skills we got. Okay, So essentially what we are doing is we are evaluating outputs here, not actually the model, or rather I should say we are evaluating prompts. So what are the scorers we are going to use? uh, Although there are like a lot of scorers, we will be using correctness and guideline. Now all these must be looking very intimidating, but essentially what we will be doing is we will be using the inbuilt guidelines scorer by MLflow, and then there are other scorers that we will be writing from scratch, which would be called as custom scorers. Okay, all right. So essentially what we want to do is from ad hoc testing to reproducible evaluation. That is the idea. We don't want to basically um, randomly say that this prompt was better. We want to show that this prompt was actually better. Okay, so that is the idea. So what I'll do is I'll just open my project folder. Now this is my project folder. I have already activated my virtual environment, and if you are new to this video, you might want to check out some of my older videos where I basically demonstrated how you can set up MLflow on your laptop and also how to get started with it. So I won't be showing all of that in this video. Okay, so let us first of all create a plan first of all. Okay, so I'll create a plan.txt file, and in this plan I will write down what would be the steps that we are going to follow in this video to set up this evaluation system. Okay, so first thing first, I want to have a resume. Now how can I get resumes? Okay, so you can basically go ahead and download some sample resumes from internet, but what I will do is I'll just use my own. So I have got my CV downloaded here on my system. If I have to show you that, so here it is it is my CV. So now what I'll do is I'll try to basically use this within my project. Okay, so the project is resume to skill extraction. So let's define some of the steps that we are going to follow. Okay, first would be we would be trying to create a data ingestion system. Although it's not a very sophisticated data ingestion system, this would also only include reading the file, reading the PDF, but this can be scaled to any number of PDFs that you might be having in your real world setting. So second step would be clean the PDF. Okay, so these two steps we will be following and demonstrating. So data ingestion is done. After that we'll set up MLflow. Although MLflow is already installed, we just want to write down some introductory code that will allow us to basically log certain things. So we will be writing we'll be creating an experiment, creating a new experiment. Then after creating the experiment, we would be importing some packages from MLflow. And then we want to create a eval data set. You want to create a eval data set, and I will tell you how that looks like, the format in which the eval data set is written. After creating the eval data set, we will be in the third step, we will be evaluating the eval data set. Okay, before that, the fourth step in the second step would be define a list of scorers. Okay, if applicable, write a custom scorer. Okay, so this would be the framework that we will be coming back to during this video. So let's get started, and let's quickly start with the project. Okay, so I'll say project1.py, and in this project first I want to create this pipeline quickly. I don't want to spend too much time on you can say cleaning the data set, but let's quickly get it sorted. So I will import the PyPDF module, and from PyPDF module I'll create a reader. and this reader will be essentially a PDF reader, and here I want to pass the stream of the PDF. So let me show look at the path of my PDF. Users, I should be having a path, users, and then Rahul, and then desktop, and then I got one CV here. So let me list down this directory. Okay, so I've got this PDF file here. So I will just grab this. Okay, and after this I'll append this name. Okay, so after getting this reader, I'll loop through all the pages. For page in, reader dot pages, and what I'll do is I'll define a I'll define a resume text variable here, which will be an empty string, and I'll just append to it all the pages. So page dot extract text. Now let's quickly look at how does this resume text looks like. Print resume text. I'll print the first 100 characters maybe. So let's print it out. Python project 1. It says reader dot object is not callable. Why it is saying that? Because we did not have to do this. Okay, you see this? It is loaded now, but it is very messy right now. There are a lot of unnecessary characters, so we would like to solve that first. Let me import rd package, and let me define a clean text function really quickly. This will take a text and return a text. So first we want to lower the text, and after lowering the text, I'll just return I'll just save this in text. And after lowering the text, the next thing that I want to do is I want to substitute all the not allowed characters. So what I want to do is I want to take my text, and I would like to substitute what I would like to substitute. So anything that is not a allowed character, I would like to substitute it with space, and I would like to apply this to text. Now what is my pattern? My pattern would be starting with R, and the pattern would be something like I don't want anything besides A to Z, and also space. So I want to keep space as the special character, and the reason I'm not keeping the uppercase A and Z, because I have already lowered the text. Okay, now let's try to return this text and let's see what happens. Although it's not complete yet, but let's see what is happening. So I would like to say cleaned resume text would be clean text, and I'll pass this resume text, and let's see how does it look like. So I would just Control C, Control V, and here I want to print the clean resume text. Okay, let's try to print that. If you see, there is not much difference right now. The only difference that I see is that objective has been lowered to lowercase. Now how can I just remove these characters, because there are some extra spaces here? So I want to get rid of that. So what I'll do is I'll apply one more substitution, and this time the pattern would be I want to remove any space which is occurring more than once with one space. Okay, and I want to apply it to text. Now you will see a drastic difference. So let me run this now. If you see, this one was the uncleaned version and this one is the cleaned version. So you see this? Okay, so now it is making sense. Now we have the data ingestion pipeline ready. Let me uncomment this print statements. Although in your real world settings, what will happen is you would be having separate scripts for taking care of all the things. You might be having a separate Python script to handle the data ingestion pipeline, separate Python script to set up the experiments and all. Okay, so I hope it makes sense. But for now, let's keep everything in this project 1.py file, and then we can take a look at how we can basically refactor this code into separate scripts. Okay, so now the next let's look at the plan. So we have completed the first step. Now we need to set up MLflow. So let us do that. So I will be starting importing MLflow from here. So first, to set up the experiment, what I need to do is I just need to call this method called set experiment, and here I will just name it as resume skills extraction prompt evaluation. Now what happens is, if you are new to MLflow, then you might be interested in knowing how does this experiment work. So there is this experiment which is at the top, and then within experiment you have various kind of runs. Each run is essentially used for doing some sort of hypothesis testing, you can say. So this is a prompt evaluation experiment. So within that we can have several experiments to try out, several runs to try out different things. Okay, so we have set up the experiment. Now at this point, if I run this, so first let me start the MLflow server. After starting the MLflow server, I can come on browser and can go to this URL to look at this. If I go inside the experiment, so we have got already some experiment, because this server has been set up as part of the YouTube playlist that we already did on MLflow. So we have already got several experiments which are currently there. Now what we can do is we can open a new terminal and we can run this script again, and this time what will happen is, one second, it will create this experiment, because this experiment does not exist right now. Okay, so I'll run this project1.py. So it's saying cannot set a deleted experiment as an X. You can restore the experiment or permanently delete. Oh, I see. So let me prompt evaluation new. Okay, let me write it as this, and this time it has created the experiment. So if I refresh it, so we have got one experiment. Now it asks me what type of experiment this is, because we are evaluating GenAI based models. We will be choosing GenAI apps and agents. Okay, so we have got this. You can come here on the evaluation runs. Currently we don't see any evaluation run because we did not run it at this point. So let's set up other things. So in the plan, we have set up the experiment. Now let's import some of the required MLflow packages. Okay, so what do I want to do? So I think I should have also in the plan written one step to basically set up OpenAI or any LLM. Set up any LLM. Okay, so let's come to that. Let's come back to the project1.py, and then let's import some packages. So I would like to import from GenAI.scorers. So we have to use two scorers, two inbuilt scorers that are available by that are made available by MLflow. The first one is correctness, and the second one is guidelines. Okay, and then we will also be defining our own custom scorer. For that we need to import a decorator called scorer. Okay, so this is it. And I think there is one more thing that we could import, although I am not sure how often we are going to use it, but let's import it. It is called feedback class. When we write a custom scorer, we can either return a boolean, or we can return a detailed output with rationale of the decisions using the feedback class. Okay, so after this I would like to create my eval dataset. So I will like to create my eval dataset. Now this eval dataset, will be a list of dictionaries. Each dictionary must have keys such as inputs. Input will be a dictionary. It could also have outputs. Now there are two options with you here. You can either create an output within here, or you can define a prediction function which will actually interface with any LLM of your choice, maybe OpenAI's LLM or Gemini's, but that's your choice. We will be setting up OpenAI, so we don't have to pass this outputs. Otherwise we would have to pass the actual output that you want to evaluate. Okay, so I would like to just take inputs here for now, and I would like to also create expectations. Now expectations would be, you can say, what are the expectations for this question. So whatever your input is, you want to understand what would be the expectation from that. Okay, so I will have a question here, and this question will be something, but let's define the expectations first. Expected response. So in the expected response, we have to define what is the expected response for this question. Okay, so now what we need to do is, why it is giving us, okay, I think I should have done this. Okay, so now this is the format that our eval dataset will be having. Okay, so in the expected response, what we can do is we can write down what I would like to do, or what I can do is I can also define other keys here in the expected. Maybe something like skills. I can define list of skills that I would like to capture for a given resume. So I can say something like in the question, and essentially this question is nothing but cleaned resume text. Now why I'm saying this is nothing but clean resume text, and in place of key I should have just added here clean resume text. Okay, now I need to define this expected response in a moment, but before that I would like to define a predict function. Now what this predict function is going to do is, it is going to take this clean resume text, and you have to name it exactly the way you defined it in inputs, and it would return the response. Okay, we would be defining the response in a moment. So what is going to be the response, and response should be a string format. So let me explicitly mention it. So it should be in a response. So essentially either you can so maybe let's do one thing. Let's for now define the response as maybe Python comma ML, just for the sake of simplicity. For now I'm not setting up OpenAI's API for now, just use this. Okay, so Python ML, let's expand this a bit. Maybe, I don't know, sklearn and linear regression, linear regression, or maybe, I don't know, machine learning. Okay, now after this, so this is my response. So I am assuming that this will be coming from where? From the LLM. Now this would be my expected response. Okay, okay, so the idea is that in here you will have a code to basically use this clean resume text. For now I am hard coding the response, but this is how it works. Okay, all right, so now what we need to do is we need to basically set up the scorers. Let's set up scorers. Scorers will be a list of scorers. So first is correctness. So correctness won't be taking any argument, because correctness is essentially an LLM based correctness measure, and what it will do is it will use the any setup LLM that you have available in your local system. Okay, then we have guidelines. Again, guidelines is also a LLM based scorer. In the guidelines, let's create a coverage based guidelines. Okay, coverage based guidelines. So I'm naming this guideline as coverage, and then we will be defining guidelines. So what exactly? So these will be human readable instructions for these guidelines. Are all the skills captured? Okay, so this is the guidelines job to tell us whether all the skills are captured or not. Finally, we will have a custom based scorer. So here custom based scorer may, let's assume we are writing one scorer called minimum 5 skills. Okay, now this scorer is something that we need to define. So let's define it right now. Define scorer, and here I can write scorer decorator. That's how we can call it. Okay, now this minimum skills minimum 5 skills decorator function, it has to accept some arguments, and the names are very restrictive. You cannot name the argument anything. So you need to pass only inputs, outputs. You could pass only inputs, outputs, and expectations. Nothing else you can pass. And what will be the value of inputs? Inputs will be exactly like this. This will be the dictionary out. Or in fact, I can even show you by printing it right now. One second. So let me show you these three by printing. So what will be the inputs? Inputs will be exactly this. And what will be the outputs? Output will be this returned string. And what will be the expectation? This will be the expectation. So the idea is that you can take these inputs, outputs, and expectation within this minimum 5 skills function, and you can do anything with it. When I say anything, essentially you have to return some boolean or some feedback based response. So you can return a feedback, also you can return a boolean. So for now, let's assume that it is passing. So minimum 5 skills are happening. We have to write the logic here within this function, but for now we are not writing logic even in predict function and also in minimum 5 skills. So now we are ready to run this, but we just defined this scorer. How are we going to evaluate on eval dataset? That's the final step. So we will call MLflow.genai.evaluate. This evaluate will take a data, and data will be eval data. So we define the eval data, and it should be in this format only. So let's define eval dataset. And then after eval dataset, we need to pass predict function. So we have already defined our predict function. Okay. And finally, we need to define a scorer. Now, right now, if I run this, it would be failing. Why? Because this correctness works on LLM. But let's try it out and let's see what happens. Okay. Okay. So Python project1.py. So we have already set up one experiment. Where is the experiment? Yeah. So this is the experiment. So this will actually create a log, and that log will be so what is happening? So we are printing it here, right? So what is happening is input is coming from here. You see, clean resume text. This is how we define input. Clean resume text, and clean resume text is a very long text. Okay, after that, what do we have? After that, we would be having outputs. What is the output? Output we return from here, and we should be having outputs here, right? So this is the output. And then we have expected response. This is the so finally we are printing expectations. Expectations would be, this is the expected response. For now, skills is just empty. Okay. All right. And then evaluation is complete. Now let's see what happens. Currently, you see correctness and guidelines did not throw any error. But let's see, what do we see here? We see a run name. If we click on it, and if we look at it, so this particular thing is called as trace. So this is a run within this experiment. This is a run, and this is a trace. And if you open a trace, in trace, if you see, this was my input and this was my output, right? Okay, makes sense. On the right, if you come, correctness is throwing an error here. What is the error? Let's expand this. The error is that OpenAI's API key is not available. That we need to figure it out right now. Okay, so so that was the step, that is set up any LLM. And in fact, you are not restricted to using only OpenAI, but essentially you can use any LLM that you might be familiar and comfortable with. Okay, so let's set up the LLM. Now for LLM, I have created this .env file that you see on my left. This .env file contains a key called OpenAI API. Now I will be loading that .env file in my environment during the run of this script. So I will say from .env import load.env, and let's call the load.env. So what happens is, this load.env expects a .env file in a given path. So I can pass a path here, or I can just leave it empty. Then in that case, load.env will look for .env file in the current directory. That is what will happen for now. And what it will do is, it will So when we run this Python script, it creates a new process, and each process have its own set of environment variables. And what this load.env would do is it will just inject any variable that are there in .env into this. Now after this line, what we can do is we can import OS and we can load the OpenAI's key. Although we don't have to load it, because essentially the correctness and guidelines metric will be utilizing those automatically using their backend code. But let's try it out. Os dot get env, and I can call OpenAI API key, and we need to define it just like the way they are expecting. So you see, they are expecting just like this, and I have defined it. I won't be opening this because obviously this contains my API key, but you get the idea. So now I have got this API key. I'm defining it in variable, but I did not have to, because I already loaded it, and these correctness and guidelines should be able to take it. Now this time it will take some time. And also, now that you have got this idea of inputs outputs, I'm just commenting it out. And let me run this project again, and this time it will take some time, because this time it will actually making the OpenAI API call using the OpenAI API key that we configured. So you see, evaluation has started, and it is taking some time, right? Because it actually went ahead and ran the OpenAI query. Okay, so now refresh it, and we will see one more run. Let's click on it, and we see one more trace. And if I click on it, you see this time correctness and was yes. What does that mean? So if I expand this, now what will happen is it it will try to look at your inputs. It will look at your inputs, no, sorry, not inputs but outputs, and it will look at the expectations defined here, and it will try to compare those by the LLM. So it says, let's think step by step. The document clearly mentions Python multiple times as a tool used in various projects and roles. It also references ML extensively through experience with things like that. So overall, all components of the claim, this are directly supported by the document. Okay. Currently, if you notice, I have not set up any prompt yet. I just loaded the clean resume text as it is. I did not tell the LLM to do a certain thing. And in the predict function, I'm just returning the response as it is. Okay. So there is no prompt evaluation which is happening right now. So the next step would be, in fact, I should have also added that here to define some prompts. So define some prompts, and we will be doing that from the portal. We can do it from code also. If you want to know, you can check out my video on how to register prompts in MLflow. But for now, let's do one thing. Let's come here in the prompts, and let's create a new prompt. Okay, so I'll create a prompt, and in this prompt what I'll do is I'll define resume skill extraction prompt. Okay, and here I will just write, you are an intelligent assistant helping the user extracting skills from the resume text. Okay, and here I'm writing a placeholder for resume text. Let's see how have I defined it. Or maybe I can say clean resume text. Okay, so and so here is the resume. Here is the resume. Okay. Okay, so here is the resume. Extract all the skills. So this is my first version of prompt. So I'll just name it as version 1, and I'll create it. So now my prompt is ready. Let's create another version. So create prompt version. Now here, from here, what I can do is I can edit it. I can say the output should be in this format. So how should I want, how do I want the format to be? I want the format to be in a JSON format, something like this. Skills, and skills would be a list of skills, and I can add comment list of skills. Okay. The output should be strictly in the above JSON format. Okay. So let's create another prompt version. So now we have got two prompt versions ready. Now let's do one thing. Let's run the evaluation. So how am I going to do that? So what I'll do is I'll define prompt versions. So versions. So I want to load two versions. So I want to evaluate two versions. So I'll loop through it. So for version in versions, and let's rename it as versions. Okay. So I'll load the prompt. Prompt is equal to prompt would be MLflow dot genai dot load prompt, and in here I want to pass the URI. So it would be prompts and the prompt name. So this is the prompt name and prompt version. So I want to write a placeholder of v here. That is why I need to have it as format string. So now I have the prompt loaded. Now I would like to format it. So I would like to write it as formatted prompt. Prompt dot format, and in here I can pass my this what was the one second clean resume text. So I can pass this variable in the format as the clean resume text. So how did I define it? Clean resume text. So now if I for now just print the formatted prompt, let's see how it looks like. So for that I don't want to evaluate this for now. I would just like to see the prompt for now. Let's run it. Okay, so we have got two prompts here. In one case it says extract all skills. Why? Because if I see the first prompt, it says extract all skills. In the second prompt, it gives a detailed instruction into how would I like the extraction to happen. Okay, let's see how can we use it now. So I would just get rid of this. Okay, now in the formatted prompt, now I would like to grab this eval dataset here. Okay, so one second, Control Z. So this was my clean resume text, but now I can replace this with my formatted prompt. Okay, so I'm loading the prompt. I'm creating a new eval dataset for each of the version, and then I can call this. Okay, but for now it's not done yet because we did not define the predict function here. So predict function is currently using the clean resume text, and it is just responding with this response, this hard-coded response. So how can I change this response to load from the prompt, to load from the actual prompt? So how can I do that? So what I can do is possibly I can define the OpenAI's interface within here. For that we need to import OpenAI also. So from OpenAI, import OpenAI, and then in the OpenAI, what I want to do is I want to create a client. API key would be API key, and here I want to create a new response which is going to be client dot chat dot completion dot create, and here I can define the model GPT-4o mini. Let's go with that, and let's write the messages. I can write the messages and the messages would be role role would be user, and content would be clean resume text. Okay, now I don't want this clean resume text here. Sorry. I want this clean resume text to match the eval data sets clean resume text. Okay, because this is what will be used here, formatted prompt in place of that. Okay, and in place of response, I want to return uh, choices dot message dot content. Okay, so this is how we can get this. So after this, we pass the eval data set, which is going to take the formatted prompt that we are passing, that we are essentially passing here as well. So this formatted prompt, and this is going to be the expected response. For now, let's don't write this minimum 5 skills function. Let's see whether this is getting run successfully or not. Let's run this. Python project 1. So it is running, but I don't see the evaluation line. Okay, yeah. So now we see the evaluation one. So it will run this evaluation, I guess, 2 times because we are running this in a loop. But surprisingly, it is taking, yeah. So first evaluation is complete. It will run one more evaluation. Essentially, we are running two evaluation for two different prompts, and I'll show you how you can actually compare the two results in a moment. Okay, so now both of our evaluations are complete. Now if I refresh it by going in the experiments, so you see there are two experiments which are basically used here. So let's look at the first one. So first one, in the input we were using the extract all skills. So it is a very simplistic prompt, the prompt version 1. In the correctness, we see the claim mentions this, the document exactly list. Okay, so this is right. So correctness is getting passed. Coverage, in the coverage, how did we define coverage? So coverage was defined via the guidelines class. That is, are all skills captured? So it says yes, the sole guideline provided are all the skills captured. The input is a detailed resume text containing numerous skills across programming languages, blah blah blah. And then comparing the detailed resume text with the extracted skills, the response captures all explicitly mentioned. So what is the response? Let's see the response once. So you see the output is so what the OpenAI is doing, it is extracting all the skills, and it is not adhering to the structure that we provided in the version 2. Let's look at the version 2 trace. In the version 2 trace, let's look at the output ones. Yes, you see in the outputs we are basically getting a, you can say, JSON with a skills, and minimum 5 skills is getting passed, coverage is getting passed. In the minimum 5 skills, for now we are just returning the true. We can fix that in a moment, but this is how it is looking like. Okay, so now how can I say clearly that minimum 5 skills? So let's see here. So let's write minimum 5 skills again. So what I want to do is I want to take my outputs. So outputs would be a string, and I would like to try to load it as JSON. So maybe what I can do is I can define another scorer, which will be something like is JSON. Okay, and it would take outputs, and if it would try to load, so import JSON try JSON dot loads outputs. So if it is successful, it will return true here. Okay, and if there is some error, we will return false here. Okay, so and I can also add this is JSON evaluation here, is JSON based scorer here. Now in the minimum 5 skills, what I can do is first I would like to do the same exact thing here. Why? Because I can count minimum 5 skills only when I can structurally load this, right? So I can say if we have the skills JSON, if we don't have we are not able to load it, then we will return false, and I can also get rid of this. Okay, yeah. So after this skills JSON, I'll extract the skills. So I can say something like if skills JSON dot get skills. If we have a key called skills, we will return something like, maybe for now let's keep as true, else return false. And then if we have the skills, I would like to count the length. So if length of skills JSON is greater than 5, then I would like to return it as true. Otherwise, I would like to return it as false. So you are able to see the picture, right? So first we try to load the JSON. If we don't have the JSON, we return false. If we have a skills, otherwise we return this. I can also get rid of this now. And if we have a skills, and the skills is having a length of greater than 5, then also we do this. Okay, so this is how we basically create these two custom scorers, that is minimum 5 skills and is JSON. Now let us run the evaluation once again, because in real world projects you just don't want the output to be correct and follow the guideline, but also you want the output to be following the coverage part and also the structure part. Okay, so let's run this one last time, and let's see how our prompts are performing, and then I'll also show you how you can actually compare them side by side. Let's wait for a couple of seconds for them to complete. Currently first prompt is getting evaluated. Or meanwhile, I'll just come here. I'll show you how you basically evaluate it. Come here in the evaluation run, open this. So if you see on the right, you see this assessments here, and if you have to compare it, so casual do run, you want to compare with funny one. Okay, let's see. Okay, I think one evaluation is completed. Let's see 1 second. Okay, so we have the evaluations ready. So let's refresh it. We have two evaluations. So first is honorable, that is with the second prompt. So we are seeing correctness and coverage here. So let's load this. Let's view this in a separate page, and let's try to see it. So you see, is JSON false? It is not JSON. Even with the second prompt, minimum 5 skills false. Why? I don't know yet, because we need to dig into why it basically is not showing us the result. But let's try to see the second one. Honorable cat is done. This one here also we are not getting the results. Why it is happening? 1 second. Output is okay. So this is expected, because we are not getting a JSON based output. But here we should be having a JSON based output. Are we getting as output anything else also? Okay, so I think to be able to see that why it is failing, we need to debug the output. But you are able to see the overall picture, right? The overall picture is that this is how we define our custom scorers, and this is how the prompt evaluation works. And to compare the prompts side by side, the way it works is we can come here and we can compare it to one run, and then these will appear like this. Okay. I see, because JSON is being written here, and that is why it is not able to parse it clearly. Oh, I see. Okay, but anyways, I think this video is already 50 minutes long. I would like to stop right here. but you got the overall idea. The idea was to show you how you can use MLflow to structurally and in a reproducible manner compare your prompts using both inbuilt scorers and also the custom scorers. Please let me know if you have any feedback. I would like to cover them in next set of videos that I prepare. Thank you so much.